Calling guys. So we are going to start with the third phase of this paper. That will be from question number 8. Now, what does the question number 8 says? Question number 8 clearly states, what does it state? It states, identify the purpose of the first pass of a two-pass assembler. Okay, now what will be the purpose of the first pass? So do remember, the purpose of the first pass is to create a symbol table. So you can write it over here to create a symbol table. Now they are saying, okay, now we do have an assembly language question. What does it say? The following table shows part of the instruction set for a processor. The processor has two registers, the accumulator and the index register, IX. Instructions are provided to you divided into opcode and operand. Then we do have the explanation for these parts. Okay, now the part number 1 says, give one example of an instruction that belongs to each of the following instruction groups. Only use the instruction given in the table. Each instruction must have a suitable operand as well. Do remember it. Okay, now they are saying data movement. So for the data movement, we can write LDR. LDR means immediate addressing. Load the number n into the index register. So, and we can also write store. Store could be the thing as well for the data movement. So I'm taking LDR over here. LDR, that is the opcode, and this said that use a use a suitable operand. So I can write it over here, LDR, and the number is provided over here, hashtag n because it is. So LDR hashtag 50, or you can write any number, not an issue. Okay, now arithmetic operator. What could be the arithmetic operator? So it's add, subtract, increment, decrement. So these could be the things. So I can write it over here, increment, and after the increment, the register. So I can add increment the index register, I can increment the accumulator register, whatever the register I am provided over here. So I can write it down, increment, accumulator. So this could be the arithmetic of conditional instruction. So conditional instructions is JPE and JPN. So over here, they have given me JPE. So and address. So address is given to me. So I can take it JPE and I can write any of the address I want to, because the addresses are not provided over here. So I can take any of the address. Okay, now they are saying the instruction LDR hashtag 2 uses immediate addressing. It's given over here, LDR hashtag 2, immediate addressing, load the number and to the index. That means 2 is loaded to the index register. Now they are saying give one similarity and one difference between the direct addressing and index addressing. Okay. Now direct and index addressing, what is the similarity? Okay, now both are loading the contents of an address into the accumulator. So whatever the content is given, both are loading that particular thing into the accumulator. First of all, we can write down the similarity. Both instructions load contents of address to accumulator. Okay, now what is the difference? So direct addressing and index addresses. So direct addressing is something access the address given by the operand. Directly, it's going to access the address. Whereas when it comes to the index addressing, so index addressing, we need to we need to create up a new address by adding the contents of the index register as well as the uh, data or the address that is provided to us. Okay, so we can write it down over here. Difference, direct addressing, uh, gives access to address whereas indexed addressing forms a new address. So this could we could write it over here. Now they are saying for the next part, identify one other mode of the addressing. So they have given us direct addressing, they have given us indirect addressing, so we can sorry, index addressing they have given, so we can write indirect or we could write relative address. So I could write it down indirect over here. Okay, now they are saying the following table shows another part of the instruction set for the same processor. Okay, so B is generating the binary number. Do remember that hashtag is representing the binary numbers. The current content of the accumulator are 0, 1, 00, and then 4 times 1. Show the content of the accumulator after the execution of the following instruction and B. So the binary number is given us 1, 0, 1, 0, 1, 0, 1, 0, and we do have 0, 1, 0, 1, 0, 1, 0, 1. So we need to apply an AND operator over here. So after applying an AND operator over here, what is the answer that we'll be getting? We will be getting 1, 1, 1, then a 0, then a 1, and rest of the things will be 0. Sorry, this one was written. So this is how we could get this part. Okay. Now they are saying the current contents of the accumulator are show the content of the accumulator after the execution of the following instruction LSR hashtag 3. So LSR, what does the LSR says? LSR over here. Bits in the accumulator are shifted logically n places to the right. Zeros are introduced on the left hand end. So LSR3 means that you need to shift these instructions 3 places to the right. Right means at this place. Okay. So this 0 will be 1, 2, and 3. This 0 will be over here. 0, 1, then 3 zeros. And they are saying zeros will be introduced at the left. So what is the disadvantage of this part? That we are losing the original bits. Okay, now they are saying the current contents of the accumulator are 4 times 1, 0, triple 1. Show the contents of the accumulator after the execution of the following instructions. XOR 0, sorry, 001, 0, 00, 10. Then we do have 0101, 01, 01. So at this similar, it will be a 1. So first time it will be a 0, then 1, then 0, then 0, then 1, then 0, then 1, and then 1. So this is how we are getting the answer for this one. Okay, now coming to the next question. What does it say in the next question? It says, question number 9. Explain the importance of a feedback in a control system. Okay, now what is the importance of a feedback in the control system? Do remember it's for the 2 marks. So feedback is telling that system operate or system is it operating within the given criteria or the set criteria or not, and the and by that thing the output of that particular system, what is the effect of that particular output or what is the effect of the particular input over it. So you may say it in this way. Mainly by checking that system operates according to, or you may say operate within the criteria, within given criteria. Okay, now they are saying give one example of an embedded system and explain why it is an example of an embedded system. Okay. So it's for the 3 marks. So embedded system. What are the embedded systems? Embedded systems are actually those systems that are microprocessor controlled, that are taking up the inputs. They are comparing those inputs and they are taking the necessary decisions over that particular inputs. So you may say uh, self-parking. Self-parking is an example of an embedded system. Okay, explanation. Well, automatically look for an empty space. If found, will send signal to microprocessor that will instruct actuators to perform required operation. So this could be the answer for this thing. So that was the last question for this, and that's the end of this paper. The paper is in 3 phases. Make sure to have a look on all 3 phases of this paper. Thank you so much, guys. Allah Hafiz for today.